In this session, we will discuss about smart grid use cases pertaining to big data. Here, we are talking about 6 key areas of use cases, starting with demand side management program, advanced metering infrastructure, wide area situational network, power system state estimation, event classification and detection, and last but not the least, system security and protection. I am covering only 6 use cases, but there are many use cases pertaining to big data and smart grid, which you can refer by searching in your favorite search engine. Let's delve deeper into each of these areas and see how big data benefits customers, operations, and related areas. The first use case is demand side management program. That means how we control the demand. The major challenge with utilities are providing power when there is a peak demand. So one of the critical aspects of demand side management program is to enable customers to shift their peak usage. And for that, there are multiple methods and programs adopted by different utilities. First of which is time of usage. So based upon when you are consuming the energy, you are charged accordingly. That will dissuade customers to minimize their energy consumption when there is a high demand. That means whenever there is a high demand, the utility will charge higher price because they have to procure this energy at a much higher rate. So when through big data management, when they provide this information to the customer, and customer can see that this is the energy charge I have to pay for consuming energy, they can reduce their usage and they can shift their load which are not required to be used at that time at later time. Similarly, critical peak pricing, and utility could decide to have very high pricing for the peak usage. There is another method which is used in the industry. It's called demand response program, where users can voluntarily subscribe to DR programs where they allow utilities to control some of their devices for specific number of period in a year. For example, if I sign up for demand response program, utilities can switch off my air conditioner when there is a huge demand, but only for specific number of times in a year. And depending upon the specific program, utilities provide credit back to the customer. And each of these scenarios are possible to be implemented is because system is generating the real-time data, and with that real-time data, utilities can provide the information to customer, and customer can make decision at that point in time. So this also helps in engaging the customer, because customer is no more just looking at their utility bill at the end of the month. Here they are engaged with utility, they are receiving the information pretty much real time or a day ahead information, and making their decision of using energy or not to use energy. This information can be presented to customers on in-home devices, or even utility can present some of this information on their web portal. There's one very interesting capability utilities could build is around budget assistant, where they analyze massive amount of usage data, uh, look at the billing information, look at what is the threshold customer has decided to consume within a month, and provide alerts back to customer saying that you have consumed say 40% of your energy within first 10 days itself. Now let's look at next use case, which is about advanced metering infrastructure. So in advanced metering infrastructure allows utilities to eliminate the need of manual meter reading. Now, with this two-way communication, utilities can get the meter data in their data center directly. It enables granular usage-based analytics. AMI infrastructure also helps utility in detecting outages. They can ping specific meter to figure out whether that meter is in use, customer is consuming the energy or not. And then one of the very important use case is around remotely connecting and disconnecting meters. Earlier, it used to take multiple days to connect a meter specifically on rented house. So if a person who is moving into house, then he may have to wait. But now with smart meters and advanced metering infrastructure, it is feasible to perform the remote connection and disconnection almost instantaneously. Now let's look at third use case, which is about wide area situational awareness. Grid consists of multiple different assets, so it is important that it is aware whether all of these systems are functioning properly or not. And with wide area situational awareness, it can receive different grid events like any voltage fluctuation event, any frequency event where there is a change in frequency and the desired frequency. And then second one is a phase angle event can also be measured through wide area situational awareness. It helps process heterogeneous data from multiple devices. And the grid anomaly visualization can also help utilities understand what are the anomalies they are seeing in a specific area. So with all this big data, wide area situational awareness is now practical to implement with smart grid. Look at the fourth area, which is about power system state estimation. Conventional power system state estimation is solved iteratively due to non-linear measurement. And these non-linear measurements used to acquired from SCADA data, which was pretty inefficient. But now, with the deployment of different sensors and new algorithm, it is possible to perform the power system state estimation in a much better way. Linear estimation model with weight assignment function relying on EMU data can provide power system state estimation. When we talk about power system state estimation, there are two main problems. One is about the bad data, and another one is about the dimensionality reduction. So bad data is like iterative process in pre-estimation, and more accurate post-estimation technique can improve the results. We already saw reasons for bad data. There may be some device which has malfunctioned. There may be a communication link which has some issue. Because of all these, there may be bad data. With the iterative process, it can be fixed. Now, when we talk about dimensionality reduction in big data, that can be taken care by principal component analysis. So with the deployment of phasor measurement unit and processing this data, the power system state estimation can be performed in a much better way, and grid reliability can be improved. Fifth area, which is about event classification and detection. Events could be like a fault, it could be because of line trip, could be because of load shedding, could be because of change in oscillation. Pre-smart grid, most of these events were analyzed after the fact. That means when that event has happened, system gets the information that there was outage in this area for this much duration. Similarly, system will get information through various means, including the manual update that there was a fault in this line. And then engineers would sit and try to figure out as part of post event analysis. But in smart grid, now it is feasible to get the data continuously, apply different models to predict the likelihood of an event. Will we have a potential fault in this line? That could be derived by analyzing the data which is coming out from various sensors which are deployed on the grid. Transient event detection using machine learning models can be very helpful. For example, you could use a supervised learning model or unsupervised learning model to detect some of these faults which may happen in the grid based upon the data which you are receiving on a continuous basis. But the hybrid model, which is the combination of supervised and unsupervised machine learning, provides better result. Similarly, like fault detection in microgrid using decision tree algorithm or a random forest algorithm can provide the insights about potential fault. So we are seeing that in smart grid we are able to perform multiple different analytics to gain the understanding of the whole grid and the specific events which may happen in the grid. Now let's look at the last area, which is system security and protection. The biggest threat to smart grid is potential cyber attack. Earlier, grid components were functioning in isolation, but now these components are connected. There are multiple advantages of connected device, but then this connection also brings in the dimension of potential cyber attack. Hence, security on the system has to be planned properly, and the data which is coming out from the grid can help in providing additional security measures like real time and tight cyber physical coupling brings a possibility of protection. So here there is a possibility of correlation of video surveillance data with the data which system is receiving from various sensors deployed on the grid. There are big data oriented crypto systems that are deployed so that hackers can not hack into the huge amount of data which system is acquiring. Big data oriented anomaly detection can also help. Similarly, big data oriented combined video surveillance and grid events as I already explained. In this session, we learned about 6 different use cases areas. In the subsequent session, we'll look at the grid analytics and the architecture which enables the grid analytics. Thank you.